each other, or they come together? Because opposites do what? Attract. Okay. So when we're thinking about static electricity, how's it created? What's that got to do with anything that we're talking about atoms? How is static electricity created? What do you think?
It can be naturally made or made by people. Static electricity when it's when an electric charge can jump from one object to another.
Okay, she says an electric charge can jump from one object to another. Okay, so, but how does that happen? How does it happen for an electric charge just to jump from one thing to the next? It just automatically jumps?
No.
What do you know? What do you think? What about this balloon? What do you think? Is it negative, positive? Do we know?
Positive.
You think positive? Do you think it has a charge right now?
No.
What do you think, Sam? Right now, it's probably negative, right? Is it like sticking to anything at all, or no? So have I like charged it up, made it charged? So right now it's probably not charged,
So it's negative.
not negative, probably
Neutral.
neutral. So it doesn't really have any more of one thing or another, right? Okay, so it doesn't have more protons or more neutrons. It's just neutral, right? Because that would make it, if they're even, then it's all neutral. But what happens if I do this? What am I doing?
You're giving charge.
I'm giving it more what? Charge. So more what?
It's like
Static electricity.
But what am I technically doing to it to give it static electricity? Bernardo.
You're rubbing it on your clothes.
I'm rubbing it on my clothes, which is creating more what?
Charge.
Charge. Okay. What kind of charge would that be giving it?
Static. No.
Is it a positive? Okay. So when you rub it, a balloon gains electrons and becomes negatively charged, while clothing loses electrons and becomes positively charged. Possibly. What do we think? What's happened here? Why is this? Why is this happening?
Because you charged it.
Because I charged it? So does that mean that...
Static
literally
electricity
touching
makes it.
Okay, so you think it's because the static electricity is making it stick? Look, I am feeling now a pull even to me. Look, watch. I'm not moving it. It's pulling to me. Which that means I am charged one way and it's another, but I just charged it. So I gave away charge and it's pulling to me because now I'm the opposite, right? Okay, so let's take a look at this and explain this a little further, okay? Okay, we're going to do a little experiment before we dive in deeper to static electricity. So what we're going to do is just do a little investigation to see for ourselves what happens, when can we create static electricity? When is it possible for us to create it, and when does nothing really happen? Okay? And why? Why do certain materials attract together, and why do some not? Okay? So, you have a list here. You have paper clip, styrofoam, small piece of paper. You have aluminum foil, okay? glitter, salt, you have paper clips,
Running water.
and you have pencil shavings and running water. Okay? So before we begin, you have your groups that you're going to work with 3 different people. And I'm going to give you about 2 minutes per station. What you're going to do with each other, I'm going to go ahead and demonstrate. So then, I'm going to give you a balloon. Okay? I'm going to give you a balloon. Now, is this going to charge better on some fabrics than others? Yes.
Yes.
Is it going to charge better on a really bumpy hoodie?
Nope.
Or a more slick surface?
Split.
Okay. So really, like, let's say if me and Lincoln are partners, Lincoln's going to go like this, so he rounds his back really good so that his shirt's all tight. And I'm just going to do this. I'm going to take it, and I'm going to rub the balloon on his shirt. Okay? Now it should have something. And you can tell if it's charged when you do this, you're going to feel it. You actually feel a little sensation of charge here. Okay?
It becomes like water.
It's static electricity. You're going to feel it. Okay? Can you feel a shock sometimes?
Yeah.
Okay. So that is static electricity. Static means what? Static. Think of that root word.
It's
Is it moving?
stationary.
Stationary. Yeah. So static electricity pretty much stays in place. Stationary, right? It's not electricity that keeps going and going like a current, right? So this is our first section of electricity that we're learning about. It's static electricity. So it is more in a spot, right? So boom, boom, boom. So that will be your balloon when it's time. Okay? So that's charged. So think about, now that the balloon is charged, I want you to think about and make a little prediction on each one of these items. Okay? So you got your salt. Okay? You have pencil shavings from the pencil sharpener, paper clips, styrofoam pieces, okay, glitter, paper, and aluminum foil, okay? So I want you to make a prediction on your paper. What do you think is going to happen? Is anything going to happen? And why do you think so? So these materials are all made of different types of things. So let's think about why. Like we can see this right now, what's happening with Lincoln's paper is it's already kind of wanting to pull his paper up. So it's kind of already answering one of our parts, right? So, okay, so why is that? Why? Right? So will it move? Will it move? I want you to answer really quickly, yes, and be thinking about why you think so. And then we're going to take a second. We're going to move into our groups and we're going to get started. Maybe. No, I don't know. We're not going to be on wishy-washy on the fence. We're going to say yes or no. What do you think? You're going to have a strong opinion on one way or another. Even if you don't know, think about just trying to reason. Okay? Think about what each of these things are made of. All right? All right, 1 minute. Let's go. Jot it down and give me a line. Okay. Okay. So, again, you only got probably a minute is long enough just to see. Don't touch the materials. The idea isn't that, oh, let me touch them and see if it works. It should electrically move toward the balloon if it's actually material that's going to work. Okay? So again, you're going to rub it, get it good and charged. You should feel if it's charged. And then you hover over. Okay? Each time you go to a new station, you're going to need to charge it again. Okay? So, we're going to move pretty quickly, so no time to dilly-dally around. All right? So, make your notations of what happens. So, again, you have station 1. Pay attention so you know where you're going. Station 1, 2, 3. This is the way you're moving. It's not necessarily what's on your paper. Okay? So, 1, 2, 3, 4, 5, 6, 7, 8. So just one big circle. Okay. All right. And so for the water, definitely don't touch the balloon to the water. I have the water going at the stream it needs to be at. Okay. Don't mess with the water. Don't go over there and turn the water up or down. Okay. Just let it be. Okay. All right. Ready? Go.
Okay. Charge it. Yeah, to his hair. He don't know. He just.
Me?
You said it like.
So, when I saw
It's like, oh.
it's that person.
What's happening? Is anything happening?
Here, hold on, let's charge us.
You feel a charge on the balloon? Can you tell?
There's nothing happening.
Okay. Try. Yeah.
Okay, so. Alright. We do it now?
Feel a charge?
Nothing. Wait, okay, so. Wait, try to see what. Put it in. It's still, and it's still the.
So what's happening?
The water gets the shape of the balloon.
It got the shape of the balloon?
No, the water. When the water is running, it like the closer the balloon gets, the more water comes around the balloon.
Okay, so the water curved.
Until away from the balloon.
It went away or towards?
It went towards.
Towards? So let's try. Show me. So you say away, you say towards. Which way did it go?
It's not charging anymore.
It's bending toward the balloon. Okay. Okay.
We did it. Yeah.
It works. So paper works.
Yeah.
Okay. Okay. Switch.
Okay, we're right there. We're done.
So what did you get?
It went stuck to the balloon.
Okay.
It was
So,
like it like didn't want to come out.
okay. All right. So supercharged.
Yeah.
Okay.
I say for it. Give me 5.
Are you seeing that certain material, certain shirt may work better than others?
Yes.
Okay. Can you explain why? You can try different people's shirts, different people's things. So Jordan has on a fleecy material. Why is it that fleecy material is working better than a t-shirt? So that's a question to maybe jot down in your journal, and let's talk about that. And when we're done, let's come up with some reasons. Okay. What were you telling me?
No. When we were doing the glitter, we put too much charge on it, and a lot of glitter got all over it.
Okay. Okay. So yes, we're gonna have glitter back. That's okay.
Yes.
But it's still on it, right? Okay, so let's see. How we do with the paper clip. Oh,
It's not really moving. It didn't work for us either.
yeah?
It didn't make the time.
Why that be?
Well, it's kind of moving. Yeah.
Because it's heavy?
Yeah. Maybe.
Because they're metal, right? So you would think the paper clips usually stick to like a magnet.
Yeah,
It's
yes.
a magnet over here.
Yeah, it's because it's magnetic and magnets stick to metal.
Right. So that might not necessarily be the case here. Okay. Okay. So now tell me, raise your hands after we've done all the experimenting. Was there anything that was not charging? Anything that did not work at all? What did you find?
Styrofoam.
Styrofoam, do we agree?
No, it worked for us.
Raise your hand if your group did get some static electricity with styrofoam. Okay, so what would that be? Why? Why would that? Why? Here. But material to shirt or
You didn't
what?
charge them?
Maybe not charged enough.
Oh, there you go. Sure.
Okay. All right. So could it be that it was charged and then you rubbed and you transported the charge? So then when you were trying to stick it to the styrofoam, that it didn't work because you had already removed all of the charge? Do you think?
Possible.
Did you check your balloon to make sure it had a charge? Did you feel that? So it did? Feel charged? Interesting. Okay. Could be, for sure.
Or instead of actually, like maybe they accidentally touched the glitter and then it stuck to the balloon.
Okay. So what else? Was there anything else that did not work for anyone?
Arthur didn't get the paper clips to work.
The paper clips to work. Was there anyone that did get the paper clips to work? Okay. So I did see the paper clips working. However, it was very small little
Yeah.
tools.
Yeah.
Okay. Of your-
Yeah.
So why is that?
They're too heavy to lift.
They're too heavy. Okay. If you think about all the materials that we used, that were all mostly very light materials.
Yeah, the ones.
Okay. Now tell me what was the best. What was the best?
Probably the salt.
The salt?
Yeah.
No.
You can hear it.
Perfect.
Is there any theory there? Why? What do you think?
Because it's so light that it hits the balloon hard enough to where it makes to where it makes sound.
Okay. It's so light, so you think it stuck better because it was lighter than anything?
Yeah.
Yeah.
Any other theories?
I realized that the stuff that have minimals in it, they work better. Like the water, it moves sideways, and the salt stays very well.
Okay. The things with minerals seem to work better. Okay. Salt is a mineral, right?
Mhm.
So, and then there's minerals in the water. So you think that might have something to do with it?
Yes.
Is there anything else? Is there any other surprise that you thought would not and it did, or vice versa?
The water I was really surprised about.
Yes.
Like I was like, water didn't move for us. Because whenever you look at it, it looks
That's
clear and there's like nothing in it. And then whenever you take the balloon, it like slightly comes.
Yeah.
Yeah.
Okay. Yeah, it bends the water.
For us with the aluminum foil, I thought it might stick better, but it didn't really even stick that much at all.
Okay. All right, aluminum foil. Yeah, that was a little surprising. Some people got it to stick. So again, I think that some of the balloons were easier to charge than others, maybe depending on the fabric of what you were charging with. Some people maybe just a little more, right?
Or maybe you already took off all of the like positive energy from the shirt or whatever.
Yeah, possible. Okay, so here's what we're going to do. Since I don't know everything about it that there is to know about all of these things and why, and neither do you, and so we have our theories. Now we're going to use our computers to see. Okay, so now we're going to research it a little bit. Just. Okay, guys. So remember, day before yesterday when we were doing science, the way we left off after our little balloon observation with static electricity was we were going to research why really we had certain objects that responded better than others and what was static electricity. We were going to do some research. So now today we are going to get in our groups and we're going to briefly research. So we're going to focus first, before we focus on the items themselves, we're going to focus first on the main questions that we need to be able to answer for the standard anyway, which is what happens when two positively charged objects come into contact, okay? And if you know any of these as I'm going over them, please feel free to raise your hand and give us a head start so that we are not having to research every single question. Let's discuss as we go. What do you think?
So first, since what happened when two positively charged objects come into contact,
believe that they each other.
They would repel from each other. Okay, so keeping that in mind with our balloon, did we see that sometimes it almost seemed like when we would rub, we were almost like rubbing charge off of it. It seemed. Okay, and so what happens when one negative and one positive charge object come into contact? Okay, Haran?
They attract.
They attract. All right. So when your hair is pulled upward, the balloon is your hair or the balloon positively. Like if it pulls up toward the balloon, is it your hair or the balloon that's positive? So that's something. What do we think?
The
Balloon.
You think the balloon?
It's getting the energy from your hair.
Okay. So how do you know that though? How do we know that you're not positively charged? How do you?
Because you're rubbing the balloon on something, so the balloon is getting the charges. So when you put the balloon on the hair, the balloon will positively charge your hair negative. So it would attract.
Okay. Okay, that does make sense. All right, I like that. Okay, all right, good. So you seem like this little observation got us a good head start. So when we go through our PowerPoint notes, bam, boom, we got it, right? Okay, how can an object become charged? I think you kind of answered that, right? How can it though? So technically, I would like for you to look that one up, okay? Number 4. When have you experienced static electricity? This is in life. When have you? Has anybody ever grabbed a door handle and shocked you? Or you go up to your mom, she's in the kitchen cooking or something, and you go up to her and you touch her and shocked.
Or you go down the slide. Yeah, I was just gonna say. Yeah.
You go down the slide, okay? Yes. Yeah, so lots of different ways we've experienced it in life, and we just kind of take it for granted. We're going to think about it, right? Okay, so tell me about it. Tell me about it. Explain it. Explain why it happened. What do you think? What scientifically happened to make that event occur? That's what I'm wanting you to put in your summary. Okay, and so is static electricity usable electricity? Why or why not? So that's another thing you might want to be sure about. Look it up. Okay? So I'm going
Today, what and how the slide? What about you go down a slide and friends there and then you touch them?
Yeah.
Like it has to be a balloon and somebody in. Okay, so it's like 4. So when two positive charges come into contact, when one positive and one negative, I haven't finished it, but when one positive and one negative charge comes in contact, it would have to turn off when it says negative, but then it's chat.
All right. Looks like you get a good start on a good paragraph here. All right. That looks good. So are you about to finish it up? Oh, you are finished? So now you can research the item that you guys had in your group and find out it and maybe a couple of the others. What makes them so chargeable? Okay. Yeah. Look those up. Okay, guys. So now everybody should be finished up with your summaries. You have written down your answers to these questions. You've written your summary, and some of you had the time to go back through and do a little research. Some of you did. So let's go ahead and let's just share. Who wants to share the summary you guys came up with? It would include most or all of this information. Okay? All right, Tyler. Bernardo.
Okay. I learned that when two positively charged objects come into contact, they will be pushed apart. The opposite effect happens when two differently charged objects come into contact. In an experiment where you rub a balloon on your hair, the hair is positively charged, and the balloon is negatively charged. The balloon is charged because of friction. Another example of this would be when you go down a slide and you touch your friend, and you and your friend get shocked. Now, static electricity is usable by scientists because they are able to harvest it, but it can't be used to power things like appliances.
Oh, I like it. All right, can't be used to power things like appliances. This is true. All right, it's not the same kind of electricity that we run our lights or our appliances on. So the next thing what we're going to do in electricity is learn about those different kinds of electricity. Now, how does it run? Do you know? Looking a little ahead. Now we know all we need to know about static so far. What, how does the electric run here? Any ideas?
Oh, I was gonna answer that.
Okay. Any ideas?
They're like conductors through wires.
Through wires. Okay. What about, do you see any electricity here?
Yes.
So
light
passage and that excellent electricity. I remember talking about like series circuits and parallel circuits.
Okay, so
And
they
then
run on
The
circuits.
parallel circuits can run whenever, like, it can still go on even when it's like, there's something missing.
Right, so you can see, for example, and then we're gonna stop, but you can see that my string of lights right here has a bulb out, right? But are the rest of them going?
Mm-hmm.
Yeah? So what kind of circuit is that?
The parallel.
All right, so we're already ahead. All right, so good job. Okay, all right, guys. So that's all we have for static electricity. Great.
Can I?
Good job on your summaries, guys. Give yourself a hand.
Thank you. When we researched that the static electricity, visible electricity, it came up with potential